Right, moving on, question number 4. So ABC are structural isomers. So again, very typical question. So they have given, I will use the board again, so it will be easy. Right, so we have a formula given C5H11Br, right? And all three isomers exhibit optical isomerism. So very good. A, B, C, they all show optical isomerism. And when reacted with alcoholic KOH, ABC gives DEF. So basically, ABC give DEF. You know, when you react with alcoholic KOH, what is going to happen? It will elimination. So minus HBr is removed. So there will be an alkene that is going to form. So alkenes are formed. So DEF are alkenes. And D exhibits geometric. So D shows cistrons, and ENF no exhibit of geometric isomerism. When reacted with HBr, ENF both give the same compound G. So these two will give same compound G. And G is a structural isomerism of ABC, and D does not exhibit optical. Okay, draw the structures of ABCD. Okay, so you just need to find the structures. That's all here. Okay, so the idea is clear. Right, so we will move on. So when HBr is eliminated, it forms alkenes. So typically you need to understand. So here when you remove HBr, there should be C5, H10, that should be formed. Okay, so this is the alkene that should form. Now we will start from the beginning. So they say ABC both are optical. So you can try to draw optical isomerism using the basic one. So I will take a carbon like this, which could be my chiral center. And I can put Br like this and one of the hydrogen like this. And since I have 5 carbons, I have taken 1 carbon here. So 4 carbons are remaining. So I can put CH3 here. And rest of the CH2, CH2, CH3 like this. Okay. So 1, 2, 3, 4, 5 carbons. 1 Br, hydrogen, 3, 5, 7, 10, 11. It is also okay. So this could be one of my structures. So what manipulations that I can change here to make it another possible structural isomers? I can put this CH3 here, and this will become CH2 CH3, and this will become CH2 CH3 then. So it is not a isomer that I can expect. Okay. And the other possible thing that I can do here is I can change this chain, because this carbon with hydrogen, bromine, and CH3, instead of having this as a linear chain, I can make this as a branch one. How can I branch this? I can put this bond between carbon and this carbon. I can put here instead of this, right? So it will be like, okay, there will be CH3, there will be CH3, and there will be a CH like this. Okay, instead of having the bond between first carbon, I can put between second and this carbon. So again, this is a chiral center. Okay, so I see these two structures are possible. So what else we can do? So with this skeleton, these two are the possible structures. But I can do one more thing. If you carefully look into this. since I have 5 carbons, I can move this Br into here and try to change the structure here. For an example like this, I can put here CH2Br and keep this as hydrogen. So 1, 2, 2 carbons are taken, 3 remaining. So I can put one CH3 here and another 2 here. So 1, 2, 3, 4, 5 carbons, 1, 5, 6, 7, 8, 9, 10, 11 hydrogen, 1 Br. Okay, so I have 3 structures here. So think about the way that I approached. First, I took as a chiral carbon, then try to put 4 different groups using the remaining carbons, bromine, and I took one as hydrogen because I want to make it simple. So this is the one I took. And then the second point is using the same structure, I try to manipulate this chain. So always remember, when you have 3 carbons in a linear chain, you can manipulate as a different branch chain. So these points should be taken into your mind automatically. When you see somewhere else again, automatically you should remember about this one. Okay, so this is one. The other thing is, after this, then I see I cannot draw more structures, but they say there is another one. So I have to change the entire skeleton again and see. So at that case, what I did is, okay, so I can put one of this Br here like this, making CH2Br, and change here. So one will be CH3, and I can change this as CH2CH3. I just put Br here and put one CH3 here. So these are 3 possible structures that you can draw. So this can be A, B, C. And they say when you do the alcoholic KOH, so we'll do the HBr thing. So when you remove Br here, so from this carbon, Br is going to remove, and hydrogen can be removed from this carbon, which is the adjacent one, or either this one. But you know, according to the Zaitsev rule, it should go from the minimum. So there will be this compound that is going to form. There will be a double bond between this carbon, this CH3, this bromine, and this one of this hydrogen will be going to remove. So there will be hydrogen like this, and there will be CH2, CH3 like this. Okay, so now this shows optical isomerism. Sorry, geometric isomerism. So cis trans can be formed using this hydrogen. So this could be our compound D. And when you do alcoholic KOH for this one, this bromine can go from here or either from here. So it will give double bond, hydrogen, CH3, and CH3 and CH3. This hydrogen will be removed from along this one. So this does not show geometry because you see there is 2 CH3 in the same compound. And when you go for this one, this could be gone from this one and this one. So this will form hydrogen, hydrogen, CH3, CH2, CH3. So typically you can understand all these 2 other structures cannot show geometric isomerism because there is 2 hydrogen here. Okay. So possibly D, E, F or D, E, F. Either E and F, it can be changed. No problem in that. So that is one of the information that they have given. Let's see what are the other questions. So we have D, E, F. And they say when reacted with HBr, E and F both give the same compound G. So we have to consider G as well. So you have E and F. Either this could be E, this could be F, or this could be F, this could be E. So we just need to see whether when you reacted with HBr, whether it gives the same structure G. So if I react this with HBr, so here the HBr should react here. So hydrogen should be added now according to Markovnikov rule. So there should be hydrogen here, So there will be a single bond like this, and there will be Br like this at the end. And here also there should be a hydrogen like this and Br like this. So you can see the compound is CH3CH2, and there is a methyl substituent here with Br, and there is a CH3. Okay, so see this CH2 CH3 is here, CH3 CH2, and the third carbon has a bromine which consists of the methyl carbon, this one, and finally there is a CH3. So these two are very same compounds. Okay, you can identify this CH2 and CH3 here, CH3 CH2, these two. Then the third carbon has carbon bromine and CH3, carbon bromine and CH3, and the fourth carbon has CH3 group, and this is this CH3. Okay, so this is not a hard question, right? This structured essay is not a hard question. When you compare to the other question that we have already discussed, like in 2011, 12, 13, 14, when you compare those questions, this is not a hard question. This is very simple question. Okay. So these are the possible structures that you can draw and identify them. Okay. So again, I'm going to share the screen now. So this becomes straightforward then. You know now, these are drawn in the board. And when you go to the other question, so write the reagents or the catalyst that you can make these conversions. So what is the first one? First one is alkene reaction to form diol. This is a diol, we say. Why diol? Di means two, ol means alcohol. So this is a diol formation. So to form this diol formation, if you can remember, we use cold KMnO4, either called normal KMnO4 or called alkaline KMnO4. Alkaline KMnO4 is better, okay? Called alkaline KMnO4. So it will give a little bit mild oxidation, and two diols will be added. So this is a benzene diazonium salt. So if you want to get into Cl to convert it to I, you just need to add Ki in the case with iodine, because it is highly reactive. But in the case with like Cl or Br minus, you need to add CuCl, Cl or either CuBr. So you know this reaction, okay? Then this is a triple bond which is converted to a double bond. So you know this is a Lindlar catalyst. So this is Lindlar, palladium barium sulfate, H2 in quinoline medium. Okay. Now these are very easy ones because they have just given you the reaction. You need to, if you know the theory well, you can get it. And there is a carbonyl bond and carboxylic groups, and there is same carboxylic, but here the carbonyl is reduced. So if you can remember here, if you use lithium aluminum hydride, this is wrong. Why? In the previous exam paper, we discussed when you use lithium aluminum hydride, it have the ability to even reduce carboxylic group to ester as well. Carboxylic or either ester to primary alcohol. So you can use here, instead of lithium aluminum hydride, you can use sodium borohydride. Okay. NaBH4. Then this is primary alcohol to carboxylic, so you can use H plus KMnO4. And this is Al2 anhydrous Al2O3 heat, or you can use Kong sulfuric because this is this dehydration. And you know this one, ammonical cuprous chloride. Hydrogen is replaced by copper. And carboxylic to acyl chloride, you can use PCl5. And amide to amine, you can use lithium aluminum hydride. Okay. And benzene to COCH3. So basically anhydrous AlCl3 plus COCH3Cl. CH3COCl anhydrous AlCl3. So these questions are very straightforward and simple in this particular case. Okay. So you need to put all these reagents in these boxes. I don't know why they have given this one. Right. Part C, write the mechanism for the reaction of CH3COCl with aqueous sodium hydroxide. So I will use the board here to explain some important information. Okay. So CH3COCl. Okay, remember. So this is a acyl chloride that is derived from carboxylic acid. Okay. So if you can remember earlier, I told you when you have these chlorines or either when you have these ester groups that is attached to this type of carbonyl, these are what I have told you before. These are good. These are good leaving groups. That is why when you have a acyl chloride or when you have an ester, when you have a grenade like this, it can attack twice, because when you react with this excess MgBr, you will see the product that you are going to get here is OH with CH3 added twice, even with the ester is same. Why? Because in the first attack, when this is attacked here, this will be converted to like this, O minus, and there will be CH3, there will be MgBr here. This one again breaks this Cl. And there will be this compound at the end of first reaction. Cl is removed because it is a good leaving group. And another molecule of grenade will come here and attack the carbonyl carbon again to form CH3. At the end, you add water, so this you can see two CH3 groups are added like this. Okay, the first point that you need to understand, when you have chlorine or either these ester groups, so when you attack this here, this will be bonding, this will be removing like this. Okay, the first point that you need to know is these are leaving groups, and it can be attacked by grenade twice. Okay. Now we will come to our mechanism. Okay, so in the similar way how grenade attacks, now here we have sodium hydroxide, right? So in grenade, we have CH3 minus that is attacking this carbonyl carbon. So here in sodium hydroxide, we have OH minus. So this OH minus will attack like this, and this one will form like this. So this will be first step, O minus, Cl, and there will be OH like this. And in the second case, this one will be taken again, because since Cl is a good leaving group, Cl will leave. So you will have CH3, CO, OH. So which gives the idea in an alkaline medium, this acyl chloride tends to go hydrolysis, forming the carboxylic acid. But don't forget, this carboxylic acid still can react with sodium hydroxide. So this is the point that many students forgot here, because they write down this mechanism and they have stopped here. But since NaOH is reacting with carboxylic, because OH minus can react with this, so you have to put another step here, that is formation of COO minus. Because there is Na plus, you can put even Na plus O minus, plus there should be water that is formed. Okay, so this is the additional step that many students forgot. But don't forget this. This is very important to know. Okay, first point, when you have Cl, Br, even iodine compounds are very little, because it does not form like this. Mainly COCl and COBr. And then ester, even if you have ester here, same mechanism. Okay, when you have ester here, OH minus attack. Then this will bond in the second step. But here there will be CH3OH. But here there will be Cl minus only. Okay, in this step, when you show this one, you should show this Cl minus as well. Because in a mechanism, you cannot miss the atoms. Okay, so try to remember this. This is the typical mechanism. Right, so this, I will share the screen now very quickly. Right, so this summarizes our discussion of the structured essay. So when you come from the beginning, so initially we had this small part where we discussed the properties of the compounds and matching their compounds, and then this structure compound, which was very informative, and then we went with the kinetic question. No, here there's a second one with the S block element. Normally this comes with many other compounds combined one, like the first question, but it is different this time. This is a P block, and this is also very informative, and this was very straightforward. And kinetics is very important and very essential to know this last point that I have explained to you in the board. And this is very straightforward with the fourth question, and these are very simple things. This is critical.